All right, hello and welcome. This is going to be our homework help video for the homework titled Exploring Periodic Data. We'll just jump right into it. Name one cycle in two different ways. What I mean here, when we're naming a cycle, we can do that by just highlighting the line itself, or maybe putting a box around one cycle. One way we could box one cycle would be kind of like this here, going from the peak of that wave over to the other peak. Let me try to do that again. Like that. And see, this unit here of the wave is what's being repeated over and over again. That's not the only way to do it. We could also start at a trough and go over to a trough. That's what it means when we could do it in two different ways. The period of the function is how long it takes to complete one cycle. So if we started at a peak, how long does it take in terms of x values to go from that peak down and back up to that peak? The period in this first one is equal to 3 units. And you'll see it also takes 3 units to go from this the bottom of this wave to the bottom of this wave over here. So any feature in the periodic function is going to take 3 units to repeat. Which is and is not periodic. This is a no. This one's a no. This one is a yes. For it to be periodic, it needs to retrace the exact same y values each period. This one's growing, so although it's oscillating, going up and down, since it's growing, it's not retracing the exact same y values. In this one, you can see this wave is kind of just a little wonky right here. So that's making that not periodic. It's not the exact same pattern each time. This one does look like it's that same pattern each time. Amplitude. So amplitude, we could just use the formula, but let's think of where the formula comes from. So the formula is, let me label a few things here. Amplitude is equal to the max minus the min divided by 2. So the max minus the min gives you the difference, the height change from the max to the min. We divide it by 2 because we want to find the height change from a midline up to the maximum or the minimum. And that midline being in the middle would be always half of this difference from the max to the minimum. So in number 7 here, that would be 1 minus a negative 1 all divided by 2, or 2 over 2, which equals 1. The amplitude of this first one is 1. That's pretty easy to see because in this first one, the x-axis makes our midline, and you can see that the wave's coming up 1 unit there, it's going down 1 unit there, up 1 unit there from the midline. All right, sketch a graph of a wave with the given period and amplitude. So I'll just kind of make a graph here. I'll probably start my wave down here, have it go up and down, up and down, up and down. But what's important, you can just basically draw the same wave every time. What's important is how we label it, the tick marks on it. So let's see, kind of started at a trough. So we'll kind of put a tick mark at every trough. And we'll say that since the period of this function is 0.3, those tick marks are going to be counting by 0.03s. Amplitude, so that we can give it an amplitude of 2. Let me put a dotted line in here for the midline. It needs to be going 2 up from that midline and 2 down. When it goes 2 down, it hits 0. It's just the way we've drawn it. So this wave is oscillating from 0 up to 4. 2 in the middle there. All right, so we've met these two conditions for that problem with our drawing here. Let's look at a few more of these. Period, amplitude. Okay, axis of symmetry. Axis of symmetry, that's got a slightly different formula from amplitude. Axis of symmetry, that's going to be max plus the min divided by 2. So that way we are averaging the max and the min to find out where that axis of symmetry is. The maximum of this one is 1, the minimum is -3. So 1 plus a -3 divided by 2 equals, that's -2 over +2, which equals -1. So the axis of symmetry, we have to call this the sinusoidal axis because it's not always symmetrical, but it always goes right through the middle, is going to be y equals -1. So like, it's not really symmetrical. I should actually change this on the homework. Not axis of symmetry, but the sinusoidal axis. Or an even better word is just midline. Halfway between the top and the bottom. Midline, I'm going to use midline more often in class anyway. But, you know, you might see sinusoidal axis sometimes. So it's good to know what it means. All right, I think that's good for this homework. This was just sort of our introduction to periodic functions. So if you've got a good grasp of just what amplitude, period, midline, what those vocab words are, you're going to do well when we start graphing trig functions. All right, have a good rest of wherever you are in your day.